Hello, my name is Sam Abbassi, and I am in developer relations with Algorand. Today we'll be going over the three new features that we just released that are Algorand Standard Asset, Atomic Transfers, and Algorand Smart Contracts, which are written in our scripting language called teal. So all of this is inside of BetaNet. What you're looking at right now is developer.algorand.org, which is our dev docs. You can find things like installing a node, Mac, Ubuntu, Docker, other Linux distros, as well as how to use our command line tool, our SDKs, and information about our API. What I'm inside of right now is BetaNet, and BetaNet is our new net, which comes just before TestNet. So all new and kind of bleeding edge Algorand features will be released onto BetaNet first. So if you want to get any kind of exposure, come over to BetaNet. We have you getting started on BetaNet page, and that goes through installing a node, getting up and running. And we also have information about the three different features just over here. So just more in-depth, a more in-depth understanding of what Algorand standard assets are, atomic transfers, and ASCs. And we also have more information about how to use them with our SDKs that have support in our four languages, so Go, Java, JavaScript, and Python. So let's actually get started. I want to start with ASA first. We have ASA, atomic transfers, and ASCs here. This is all using the JavaScript SDK. So go ahead and make sure you have an updated copy of the node modules, and let's get started. So here you need to configure this to your own parameters for your own node or an API, depending on what you're actually tapping into. So here I just have my algo token, the URL for BetaNet, and here we're just defining some basic blockchain parameters. You'll see this throughout the rest of the examples. Just wait for confirmation functions and things to make our development process just a bit easier. Here is kind of where it starts. So we first need to recover our accounts, and we do that by defining a variable and supplying that variable with our mnemonic phrase. So account 1's mnemonic phrase is this, account 2's is this, and account 3's is this. You can do this using our command line tool called goal, and you run goal account export -a and then the account name, and that will export, and then you have to actually specify which data directory, but that will then output the corresponding mnemonic phrase. Now we have to convert we have to get the secret key. So we run algo SDK mnemonic to secret key. We run that function, and we get and we have our recovered account now with our secret key. Now you initiate the algo wrapper, and here we start our code. So here we're going to define the parameters of our asset. So this will just be some arbitrary data to be stored in the asset. We can leave it as undefined here. Our address for our asset, so our asset creator will be our recovered address 1. We're going to set the default to frozen. So Algorand standard assets have several different things that you can do with them. Now, because this is more of ERC20-like functionality, you are literally representing some type of potentially some type of NFT or set of NFTs by different parameters within the asset. So you have your total issuance number, you have your UINT name, your asset name, a corresponding asset URL that you can define, some sort of optional hash commitment if you'd like. And then you're also going to define who the manager is, the reserve, the freezer, and the clawback. So these are 4 functions that are native to all Algorand standard assets. And if you don't specify these parameters, they'll default to the asset creator. And in this case, we're setting the manager to recovered account 2. So this is separate from the creator of the asset itself. What this means is that whoever account 2 is will have privileges that only a manager has, privileges that only the reserve address has, and privileges that only the freezer and the clawback address have as well. Just to give you an example of what these do, clawback can quite literally just take an asset back from another account. Freeze can also freeze the asset as well. Now, these are native to the blockchain because for certain financial instruments, these are things, and for certain regulatory purposes, these are things that need to be, or it's better to have them native to layer 1 instead of arbitrarily having to define them on an ongoing basis. So after we define the asset, we then have to sign and send a transaction that allows the address to create an asset. So here we're using Algo SDK make asset create transaction. We're passing in the address, our fee, first round, last round note, our Genesis hash, Genesis ID, and then our asset information. So the total issuance, whether our default frozen is true or false, and then what respective addresses these all correspond to. And again, the name, the unit name, asset name, URL, and then some optional meta hash data. These are both optional parameters. Now we sign the transaction, and you have to now sign the transaction with the creator's secret key. We run that here with our signed transaction. We are now sending the transaction. So this is broadcasting the transaction to the blockchain. Just ran a quick print statement here just to confirm that we actually did send the transaction with the corresponding ID. And now we just want to get some more information about the asset, which is what we're doing here with the asset ID. So now with asset configuration, we can make some configuration changes to what account can do what. So this basically means that we can revoke and grant privileges to different accounts based on what we want to do. So first we update the changing transaction parameters here. Now we're going to define who the new manager is. So what we're going to do is we're going to change the manager from recovered account 2 to recovered account 1. Now remember here when we created the asset, we set the manager to recovered account 2. So now we want to change this to recovered account 1, who also happens to be the person that, or the account that created the asset over here and over here. And we signed it here. So we're going to define this transaction called C transaction configuration transaction, and we're going to run algo SDK.make asset config transaction. We are going to pass in the current and existing account manager because that's the person that has to sign off. And we're going to pass in the new manager here, which was defined here as recovered account 1. We're going to sign the transaction as normal, and we're going to send it. We're going to wait for confirmation. And again, get asset info and print asset info. And now we move on to opting into an asset. So in Algorand, to receive an Algorand standard asset, you have to opt into it. Your account has to opt into it. The way you do that is by sending a zero balance of that asset to yourself. What this does is that it increases your balance record and should prevent spamming, basically. So no one can simply send you as many assets as possible. So here we define a sender, which in this case is recovered account 3, and a recipient who is also that sender. Revocation target and close remainder 2 can remain undefined. Amount is also 0 of that asset is what you have to send. Here we can just account for the changing transaction parameters. And here's where we define our transaction. Here's where we create it. So we here define opt-in transaction, algo SDK.make asset transfer transaction is what we have to run. Here we have our sender, our recipient, who are the same accounts in this case. Close remainder 2, revocation target that are undefined, our transaction parameters, and our amounts, which is at the 0, and the corresponding asset ID. Here's where we sign the transaction with our corresponding account secret key, and then we send the transaction. Now the next thing is transferring a new asset. So now that account 3 can receive the new tokens, we can transfer tokens in from the creator to account 3. So we have to define a sender, account 1, a recipient, account 3. Again, revocation target and close remainder 2 can remain undefined. Here in this case, the amount of assets that we're going to transfer is 10, which is an arbitrary amount. Again, we'll account for changing transaction parameters. Here we'll define the transaction, so it's XTXN, algo SDK.make asset transfer transaction, and again, define the sender, the recipient, and just all of the standard parameters, or at this point, standard parameters for the transaction. Same thing, we sign it, send it, run and wait for confirmation, and we should print that statement as well. Now, the last couple things we can do is freeze the account. So, for instance, let's say we want to freeze this asset. We want to freeze this asset for account 3, who now has 10 of this asset. So the freezer, if you remember, is account 2. So if we go back up top to the way beginning, we defined the freezer as the account 2 address. And that wasn't changed later on, because what was changed was the manager. So account 2 is still currently our freezer. So from account 2, who's the freezer address, to the freeze target address, which is account 3, and our freeze state parameter in this case is going to be true. Again, we're going to account for the changing transaction parameters. Here we'll define our transaction, freeze transaction, which equals algo SDK.make asset freeze transaction, and we'll pass all the parameters here, last of which is the freeze state, which is set to true. And again, we're going to sign it, and we're going to send it off the net. And I believe it's the last thing. The last couple things that we're going to do is revoke an asset. That should be revoke in assets. Revoke an asset along the same lines. So sender 2 in this case is again the clawback address. So we're going to look back up top very quickly, and we can see that here clawback was defined as recovered account 2. So we'll go back down to a revocation, and we'll basically do the same thing. So in this case, we want to revoke all the assets from account 1. We account for the changing transaction parameters. Here we define the transaction. So signing and sending the transaction will send the amount assets from the revocation target to the recipient if and only if the sender equals the clawback manager for that asset. And in this case, the sender, which is account 2, was defined earlier as a clawback address, so they're good to go in this case. Same thing, we sign the transaction and we broadcast it to the network, and we'll get our corresponding transaction confirmation information later on. So the last thing we're going to do is destroy an asset. Now for destroying an asset, again, same sort of thing. We're going to account for our changing transaction parameters. We're going to define who our destroyer in this case is, which is account 1. And it's important because the only authority agent in the network who has the privilege to destroy an account is only the manager of that account. So we first defined the asset, and the creator of that asset was account 1, and the manager was set to account 2. Later on, we saw that we changed with the transaction configuration, we changed the manager from account 2 back to account 1. So now that we're destroying the asset, we have to pass in account 1, who is the manager. We're going to define that transaction here, destroy transaction, and pass in all the corresponding information here. So really, the only thing that's changing here is who the sender in this case is, which is account 1, the manager. Same thing, we sign it, send it off the net, and get our corresponding information. So let's run this very quickly. So let's see, node, and this is asa.js, just to confirm. So this will take some time as we're getting information about each of the transactions that we're sending over the network. But here you can see where the transaction was confirmed, the asset unit name, and the asset ID, and then metadata about the asset is also displayed here. All right, so while that's running, I want to move on to atomic transfers. Now, atomic transfers are basically the way for you to atomically transfer any sort of asset layer 1 on Algorand. So again, these assets can be different fungible tokens, non-fungible tokens, any kind of combination. These transactions will be grouped together, batched, and then sent as one across the wire. So this really does kind of dynamically change how Algorand functions. This is an example also using the Algorand JS SDK. So same kind of deal. We are defining the accounts here with their mnemonic phrases. We are now defining the parameters for a transaction here. We're converting the account mnemonic to the secret key here using mnemonic to secret key, and we're storing that in recovered account 1, 2, and 3. Here we are defining the transaction. So just like normal, you're going to define transaction 1, transaction 2, transaction 3, and these are standard transactions. So account 1 is sending some amount of algos to account 3, the corresponding parameters, last round, fee, Genesis ID, Genesis hash, and there is also a corresponding amount. So again, very standard, 3 very standard transactions. What we're going to do now here, and I just want to quickly kind of summarize how this works again. So what we're doing is we're creating the transaction, and then we're going to, there's really 4 steps: creating the transaction, grouping the transaction, signing those group transactions, and then sending those transactions to the network. So this is the transaction creation. This is here. Here we're now throwing all the transactions into one transactions array. Here we're now going to just recover or throw in the secret keys for the respective accounts into a secret key array. And then here is where we're signing the transactions. So just made a quick for loop that's running through, that's signing each respective transaction, and then is pushing that into our sign tx variable. What's that? Once these transactions are signed, so now each respective transaction has been signed. Each respective transaction has also been assigned a group ID, and now we'll be sending the transaction over the network as normal. So okay, and here our ASA JS file completed. I'm not going to go back into that to confuse you, but let me just run this atomic transfer JS file quickly. So node atomic transfer JS. So yeah, I just threw in some print statements here, but here's our transaction confirmation. So this is actually probably the shortest of the features with respect to what we need to show. Again, just the possibilities are very, or I guess the process is very simple. You create your transactions, you group your transactions, you sign those group transactions, and then you broadcast that transaction over the network. So the final thing we need to go over is Algorand standard contracts. So Algorand standard contracts is our way of throwing logic around Algorand assets and Algorand transactions. Now, like I said before in the beginning, ASCs are written in teal, which is our Bitcoin-like scripting language. It's got about 30 opcodes, and this is inline transaction logic, and also each teal script is designed to be 1 kilobyte long, similar to our note field in a standard Algorand transaction that can also only accept 1 kilobyte of data, and that's obviously done so for performance integrity. So here in ASC, again, we're going to define the standard things like our token server and port. Here we're going to just define one account, and we're going to do it the same way we've been doing it, which is using our mnemonic phrase. Now, just to, well, not to reiterate, because I haven't actually said this, but just to be clear, this is not the recommended way to recover an account. We don't recommend ever sharing your private key. This is just for ease of use and for demonstration purposes. So we're going to recover the account here, and we're going to recover it. We're going to recover the secret key through the mnemonic, just like we did before. I'm going to print that out, and then instantiate the algo D wrapper. So let's get to the interesting stuff, which is here. So let me pull up this other document so I can actually log. So what we need to do is we need to define a program, or we need to define a variable. In this case, we're calling it program. That's a uint8 array, and we're passing in a hex dump. So when you're using Goal, you compile a teal program, and that's then put into a .toc file. Now you then just run a hex dump of that .toc file, and that will give you an output that looks like this. So now this will actually give us a uint1, which will pass. But just to be clear, if you pass in a int 0 that will never pass, that logic will never actually execute, and it'll look like this. So we'll run through both examples so you can see the difference. Here we're logging out our program. We're going to define what our lsig is. So we run algo SDK.make logic sig. and pass in our program. This signs the logic with your account secret key, and it's basically giving your key authority to anyone with the LSIG. So if the logic returns true, you need to exercise extreme caution. And also, if this were an escrow account usage, you would not do the sign operation. But because it's not an escrow account, we do run the sign operation, and we just sign the LSIG with the recovered account's secret key. So at this point, you can share the LSIG off and share your delegation signature. The logic SIG class supports serialization and provides the LSIG .2byte and from byte methods to easily convert from file saving and reconstituting logic SIG objects. So here we're going to create the transaction now. We are going to sign the logic SIG transaction, passing in the transaction object and our LSIG, and then we're going to broadcast that off to the network. So let's run that, see how that works. So node ASC1.js. This is about address true, object, program, and then our transaction ID. So just to show you what happens if you do have int 0 and you pass that hex dump in. And so the transaction fails. So let me just change this back to what it was. Run it again just so you can see the true statement. Yep, and it passes. So that's just a very quick and very brief introduction to how to use our 3 new features. So Algorand standard assets, atomic transfers, and Algorand standard contracts. And again, these can all be found here in BetaNet. So just go to developer.algorand.org. In the menu on the left, just hit BetaNet, and that'll give you both a getting started guide, which is just how to quickly get your node up and running, and what these 3 new features can do. Thank you very much.